All right, let's talk about binomial coefficients. This notation right here, where you've got the parentheses and n over k like that, that's read as n choose k. And what it does is it tells us the coefficient of x to the n in x plus 1 to the nth power. And the formula that we have for n choose k is this right here. So let's use that formula and do a few of these. So let's compute 8 choose 3. Well, from the formula, we've got 8 factorial on top, and then 3 factorial down here. Let me write that a little better. So I've got 8 factorial on top, 3 factorial here, and then the n minus k, well in this case n minus k is 5, so this is going to be 5 factorial. So I'm going to just, let's work this out. I'm going to do this kind of a silly way on the first one. 8 factorial is 4320. 5 factorial is 120. And 3 factorial is 6. So if I take that 40,320, divide it by 120, divide it by 6, I get 56. Okay, now this one is going to be 10 factorial. Then downstairs I get 6 factorial, 4 factorial. So I'm going to just do that on my calculator. 10 factorial is, well, this number we saw a minute ago, divided by 6 factorial gives me 5040, divided by 4 factorial gives me 210. And then 10 choose 6. This is interesting. 10 choose 6, I get 10 factorial on top because my n is 10. Now my k is 6 in this case, so I'm going to get 6 factorial here. And then over here I've got 10 minus 6, so that's going to be 4 factorial. So notice this is going to be 210 as well. 210 is the, it's 10 choose 4 and it's 10 choose 6. So that actually leads us to this little fact right here. If you have n choose k, that's equal to n choose n minus k. And let's see, I didn't put this in here, but I want to talk about it for a little bit. The reason this is called choose is because it tells you the number of subsets you can pick. Suppose you have suppose you have 5 things, A, B, C, D, E. 5 choose 2, that's the number of different 2-element subsets you could pick. So if I wanted to pick just 2 of these letters, 5 choose 2 is going to be 10. And the subsets I could pick would be A, B. I'm picking all the different 2-element subsets of this set of 5 elements. So AB, AC, AD, AE, BC, BD, BE, CD, CE, and DE. That's all the different 2-element subsets I can pick. So let's count them up. It should be 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Why am I saying it should be 10? Because 5 factorial over 3 factorial, 2 factorial, that's 120 over 6 times 2 is 10. I had that memorized. I know 5 choose 2 is 10. Now, why is 5 choose 3 10? Well, you can think of it as like the complement of all these sets down here. On each one of these, I said let's pick the different 2-element sets. Well, if you think about it, if you pick AB, if you think about what that leaves behind, it leaves behind the complement, which is a 3-element set. The complement of AC is this 3-element set. So it makes sense that you can either choose 2 to keep or choose 3 to leave behind, and you wind up counting the same stuff. So that's the reason this is called choose, is because it's the number of subsets of that number that you can choose. Let's do one more example. Let's say we did 10 choose 0. Well, what that would be is 10 factorial over 0 factorial and then 10 minus 0 factorial. That's just 1. So how many ways can you choose 0 elements from a set? Well, choose nothing. That's the only option you have. All right, so that was a bit of an aside. We just talked about this fact. This tip right here is going to make computing these things easier. Because, you know, up here I did all these computations of finding 8 factorial, 5 factorial, 3 factorial. But this tip says you can compute n choose k using this formula. Now, before I even read the formula, I'm going to use it and show you how to do it. And then we'll come back and look at it. So 11 choose 4. On the bottom, I'm going to do 1 times 2 times 3 times 4. And on top, I'm going to put the same number of numbers, but I'm going to start at 11 and go down. 11 times 10 times 9 times 8. That's exactly what this says up here. And I'm sorry, there's supposed to be an equal here. I'll fix that. I'll fix that on your notes, but I'm not going to fix it here other than just writing an equal in. What this says is we've got n times n minus 1 down to n minus k plus 1. Down here, this is 1 up to k. So what it is, we've got k terms on the, or k factors on the bottom, and also k factors on the top. So we get this. So this 11 choose 4, I can just run this through on my calculator quickly. 11 times 10 times 9 times 8 divided by 4 divided by 3 divided by 2 divided by 1. I guess I didn't really need that divided by 1, but I had the momentum going, so I wound up with 330 there. All right, so 20 choose 3 using this tip. The 3 tells me I'm going to go up to 3. And the 20, 19, 18. So 20 times 19 times 18 divided by 6. This gives me 1140. And this last one's kind of interesting. 1,000 choose 2. So I've got 1,000 times 999 over 1 times 2. So it gives me 49.95 with 2 more zeros behind it. So 499,500. Why did I say that one was interesting? Because using the tip here, we can compute this in just a few seconds with calculator. I guess we could do it in probably a minute without. But if you try to put this into your calculator by putting in 1,000 factorial divided by 998 factorial and then divide by 2 factorial, it's going to choke your calculator. So anyway, the tip is very useful for computing these things. All right, so that's how to compute these binomial coefficients. We'll look at how to use them in the next video.